Hi, I'm Ike Ellis, and I'd like to talk to you about the beginning basics of a cloud data platform. You might see a lot of different diagrams from vendors like Microsoft or Amazon about how to build a cloud data platform, and they might use vocabulary that is uncomfortable or unfamiliar to you. The purpose of this video is to simplify what a cloud data platform looks like so that you can recognize the key elements and what each element does. But before we start that, let's talk real quickly about what data modeling and data platform architecture actually is. When you create a cloud data platform, you are effectively modeling the data. And what you're doing when you do that is you are deciding where the data is going to be stored and how the data is going to be organized. Those are the two things you're choosing. And you're doing it according to your requirements. Those requirements will largely come from the business, from security, and from any technology limitations or guardrails that you might have. So when you look at a basic data platform, there could be other elements here. There could be a lot of variation here, but fundamentally, these are the major pieces of a cloud data platform. All right, so let's talk about what this diagram is. Over here on the left, you have various data sources that you do not get to control. You might want to bring in data from different applications, from vendors, from different websites, from random source files, from Excel. So you're bringing in data from an unknown number of places and an unknown variety of places. And then over here on the right are people who want to use that data. They might want to create reports, use visualization tools like Power BI or Tableau. They often will want to use Excel, and they'll maybe use it for machine learning or advanced analytics. This on the right side is another set of things that you can't really control. As you're building a data pipeline or data platform, you are focusing here on the middle pieces here. And the middle pieces are broken down into two main categories: data storage, which is how you will store the data, and data processing, which is how you will clean and transform the data. So those are the two things you're deciding on. When we talk about data storage, we're talking about whether or not we're going to keep the data streaming, and we'll discuss this in a slide in just a little bit. We might keep the data in files. We might keep it in file storage, kind of like a hard drive of storage, only we put it in the cloud for a variety of reasons. We might put it into data marts. Those are largely relational stores like AWS Redshift or Azure SQL dedicated pools or GCP Google Cloud Platform BigQuery, but it could just be a SQL server someplace, right? So we're going to keep it in relational storage. That's where we usually keep our data marts. And then data virtualization is the idea that no matter how we store the data, we can keep a common semantic layer of table definitions over it so that we can query it the same way, which means even if the data is stored file-based, we can write select statements against it and query it and get the data out of it like we would write select statements against any data store. And we might store aggregations. Aggregations we'll talk about in a slide coming up, but effectively an aggregation is us summarizing, we get from our data sources, we get one level of granularity, and then with that granularity, we're going to summarize it so that we change the granularity of it, right? So if we're getting orders, we might say, okay, give me the orders by day, by region, or by store, or by employee, or something like that, right? That's an aggregation layer. And we can decide how to store the aggregations. Okay, so that's all data storage. Down here at the bottom, we're doing data processing. Data processing is anytime we write code to change the data or organize the data at all, that is a data processing pipeline or process. And we could have a lot of these things. We could have hundreds of different little snippets of code that are cleaning and organizing the data. And because you have hundreds of them, you might need to orchestrate it. Orchestration is deciding what runs first in what order and what happens if something fails, whether it retries or it alerts somebody or it goes on another workflow path or something like that. Okay, so when you build a data platform, this is fundamentally the decisions you're making and fundamentally what you're building. And it really doesn't have to be that complicated, right? So when we talk about file-based storage, this is not your grandpa's CSV. We're not talking, now we could be talking about CSVs, but typically when we want to get into file storage, we want a Parquet file. And you could see that on the top bullet, .parquet, Parquet. Parquet files are much, much better than CSVs because they're highly compressed, 10 times compression. They are partitionable, which means that you can have multiple processes look at a Parquet file at the same time without just locking everybody else out. So that means that they're scalable. You can have a lot of different processes reading it at the same time. They can have some indexing ability in there. They have columnar indexing, which means that they are very fast to scan and ingest data, which makes them ideal for building data pipelines. So typically what you would do is you would grab something from your data source and you would build a Parquet file off the data source immediately without changing too much of the data. We call that raw storage, and we'll get to that in a later video, not this video. So this is a perfect thing for analytic platforms because we can scan the data multiple times. It's super quick, it's compressed, which means it won't overload our data I/O paths. But most importantly, it's very, very cheap. It's affordable. So AWS S3 or Azure Data Lake Storage is a very, very affordable way to store long-term data, lots of data. Fundamentally, when we create an analytical system, we really like to duplicate data. We might duplicate data for snapshotting the data. We might duplicate it for different purposes. Maybe we have one set of data that we use for machine learning and another set of data so that the finance department can make a decision, right? File storage makes data duplication very affordable because data virtualization says that you could have a database, just like a SQL Server database or an Azure SQL database, right? And you could create a table, like create customers, cust ID, company name, with data types and nullability and primary keys and foreign keys and all the stuff you love, right? But you also have the ability to create an external table. This is a metadata layer or a semantic layer over your data. These external tables allow you to keep the data staying in Parquet files while you put a definition of a table over it. And this allows you to do something very powerful. It lets you select star from customers, which is a regular relational database table, join orders, which is a Parquet data table, and then join it and filter it and aggregate it and window function it, CTE it, subquery it, whatever you love to do in SQL, you can do in something with data virtualization. And there's a lot of different data virtualization technologies out of there. I really like the Azure Synapse dedicated SQL pools Polybase. I like Polybase as an implementation. But there's like Spark virtual tables in Databricks and in other Spark implementations. They have that in Synapse, also a different metadata layer in Synapse if you want to use that. They have it in Hive and Hadoop and other distributions like that. So it's not a unique thing to any particular vendor. It's common across most data platforms. They have some type of data virtualization. And it's very powerful, lets us organize the data and give basically an interface to all of our files. And no matter where the data is stored, it could be stored in 10 different places. We can create a common way of querying it and looking at it. So when you decide where to store data, I created this slide to help you make that decision. You can store it in files, in a relational store, in cache, or streaming. Now, I don't want to just speak to this slide. You can pause the video and read this yourself, but you'll get the idea that file storage is cheap, but not as interactive or fast. As you move over to the right, you get more interactivity and more expensive, but the expense makes it very bad for long-term storage. So you keep shorter and shorter term data as you move to the right. Now let's talk about that aggregation layer that we talked about earlier. So when we talk about aggregations, we're talking about adding a fact, right? Like what's my total order amount by year, right? That's a summarization, right? Or count my total locations by region. Or give me my average employee salary by job title, right? Those are all aggregations. And that's really why we're building analytical platforms, so that we can get to the heart of this analytics and aggregate all those things by a whole bunch of different dimensions, right? By employee, by region and geography, by product type, by date, right? Date's very popular, right? So you've got three choices when it comes to aggregations. You can either calculate the aggregation when the report runs. That is a very bad choice. I would never do that if I could avoid it. The reason why is because we tend to have like 700 reports. And now every time a report runs, 700 different reports are doing the same math, which is very expensive in compute. We already talked about how that's really expensive, right? Price-wise, right? That'll cost a lot of money. But it's also very hard to make it consistent. If that calculation changes, you have to change it in all 700 reports. And if you miss some reports, you have now decreased trust in the data. Now people really don't know like if that data is valuable or trustworthy, right? So we really prefer to do the latter two things. We either create our aggregation tables by hand, or we use some type of analysis engine, cube engine, like Azure Analysis Services is a good example, or Power BI data models and Power Query models are another good example, along with DAX, right? So I prefer using a cube or analysis services engine because when you load in all your data into, for instance, Azure Analysis Services, it will automatically create all the calculations for you by every single dimension you would have in there, right? And it does it very quickly, it does it automatically, and it's 100% consistent. If you decide to store in an aggregation table, and many data professionals prefer that. Dustin Vanoy, who leads the San Diego Data Engineering Group and is my colleague, he prefers aggregation tables, and he's very, very good at his job. What's the downside of doing that? Well, you have to keep everything consistent in your data pipeline. So you would have your ETL process or your data pipeline process build the aggregation tables. And if you change the calculation in one place, you have to change it in every place in the data pipeline. So when you build an aggregation table, let's say you do total orders by year or by region or by product, you would have to make sure that in the pipeline, you're doing that math the same way every single time for consistency's sake. Where in using Azure Analysis Services, for instance, and using a cube engine, that product will do it for you. You don't have to keep everything consistent. It's much, much easier. Now, the downside is the cube engine will be expensive. You'll have to pay for that. You'll have to pay for the compute for it, and you'll have to pay the licensing costs for it. If you build it by hand in the data pipeline, you don't have to pay, right? Obviously, you're doing all the work, and it's just your time that you're paying for, right? Now, data pipelines are how we change the data. What do we mean by changing the data? Well, like removing bad rows or combining columns or splitting columns or changing data types or replacing values. Any of those things are changing the data. So on the left, we have a list of the things that we could do to change the data, and there's a lot more we could do, right? On the right are the different products that we could deploy in an effort, or a combination of those products in an effort to do that work. So we might do some things in stored procedures, some things in Python and Pandas, some things in Spark and Databricks, some things in Synapse and different processes in Synapse, right? So there's a lot of different ways we can change the data. And as a data engineer, it's our job to learn the best way for the best problem. So we can choose a mix match of this. We don't have to just choose one and stick with it. We can do 5 or 10 different things according to what the need is. So we build data pipelines like that. And we'll talk more about that in a later video. So a data pipeline might look like this. We have source systems. We copy a bunch of data to raw folders in Azure Data Lake Storage. We clean the data using SQL statements and stored procedures. We store that in an enriched folder in Parquet files. And then we might go and use Databricks and Spark or Synapse and Python to create star schemas and store it into different Azure SQL databases or Azure Synapse dedicated SQL pools or wherever we decide to store it, right? And then we decide to create aggregations, and maybe we store that in analysis services cubes, and we allow DAX to create the aggregations, or maybe we use aggregation tables like I told you Dustin prefers, and we create pipelines to build those aggregation tables, right? The point is, in order to go from source to the destination, we are generally changing and moving the data as little as possible at first, and then moving it and changing it more and more as we get to some type of curation or serving layer at the end of the data pipeline. So We typically need something to do orchestration. If we're going to have all these processes to move and clean, you would want to use like Azure Data Factory or Apache Airflow or something like that to do some type of orchestration to decide what happens first, what happens next, who gets notified, and when they get notified. In streaming, imagine that you have an application, and every time that application makes a change, it notifies you. It just says, hey, I added a record, I deleted a record, I updated a record. Something went down, like my data feed broke, or the truck stopped, or the manufacturing device broke, or something like that, right? And they've got a feed where they're just constantly chatty and talking about that. We can put a process in our data platform that monitors that feed and reacts to it. And maybe it stores all the events. Maybe it summarizes the events. Maybe it notifies people if there's something we're really worried about. Maybe it visualizes it. Maybe it streams it all the way to a dashboard where we can look at it and see what's going on with our manufacturing pipeline or our shipping trucks or whatever's happening. That streaming is also part of a very mature data platform. So that's it, you guys. I just shared with you all of the components of a data platform, and now you know, and we will talk in later videos about how to build these things, what it looks like in Azure. Maybe we'll take a look at what it looks like in AWS too, and you'll see how to build star schemas for a curation layer and slowly changing dimensions. I plan on talking about a lot of these things in future videos. I'm Ike Ellis. I'm the General Manager of the Data and AI practice at Soliance. I lead a team of data professionals who love all things data, particularly cloud data. They are conference speakers, book authors, professionals with lots of experience, thought leaders. They love transactional data, analytical data, data science, advanced analytics. They have advanced degrees, and they love working and training and teaching and helping data projects. So if you have a data project, reach out. We would love to help you. Thanks.